So section 12.3 is going to ask us to solve 3x3 system equations or applications of 3x3 systems equations. So in addition to getting all the fun of solving a 3x3, you also get the fun of setting up the equations, figuring out what the equations are. Now we practiced in 12.2 finding the equations. So here we're going to practice just setting up the equations. We're not actually going to solve them. You can practice solving them at home, but in this section I want you to practice setting them up. Or at least in class we're going to practice setting them up. At home you can do both. We're going to start with a nutrition problem. So the goal here is to create a combination of these three foods that have a certain amount of niacin, a certain amount of zinc, and a certain amount of vitamin C. So this is actually an improvement on the previous book that we used to have. The previous book had an equation where you wanted, just a little bit of carbohydrate, a little bit of protein, and a whole lot of fat in your diet. I don't know what they were thinking when they did that one, but they didn't consult my dad, who also teaches nutrition here. In any case, 1 ounce of each of the three foods has a vitamin and mineral content shown on the table. How many ounces of each must be used to provide exactly 22 milligrams of niacin, 12 of zinc, and 20 of vitamin C? So at least these seem reasonable as opposed to, like I said, our old book. Now what you don't know is how many grams of each of these you want to use, or how many ounces of each of these you should use. But we do have some constraints. We want the niacin from A, B, and C to add up to 12. So that gives you kind of a suggestion as to an equation. How much niacin do you get from food A? Well, the table tells us you get 1 milligram. So A is going to stand for the number of ounces of food A. And likewise, B is going to stand for the number of ounces of food B, and so on. So that's our A, B, and C. And depending on how much of each of these I have, I'm going to get certain nutrients. So for instance, I'll get 1 gram of niacin for every ounce of A, plus 2 grams of niacin for every ounce of B, plus 2 more grams from every ounce of C. What do I want that to total up to? 22, wasn't it? Yeah, 22. So that's my first equation. What's the second equation going to be? Can anyone write that one down for me? Well, how much zinc do I get from food A? And what's that going to equal? 12. So 1A plus 1B plus 1C. Now you don't need to put the ones here. I'm including them just so that you can see where these equations are coming from a little bit better. But you don't need to put them there. I'm putting them there so that it corresponds to the table a little bit better. Try and write down the third equation. So try for yourself to write down that third equation pertaining to the amount of vitamin C that we're going to have. What's that third equation going to look like? Let me pick on somebody. Good. 2A. I'm going to put plus 1B just to make sure that you guys are seeing where that comes from. Plus 2C equals 20. Are you okay with where we came up with the system of equations? So what I like to do for problems like this is I like to separate it. I like to separate it into two parts. I'll give you a problem on the test where I say, just set up the system of equations. And this right here is where I want you to stop. Because if I say set it up and solve it, you may be really good at solving it, but if you set up the wrong system of equations to begin with, then you're stuck. So I make them two different problems. You'll have one problem where it says set it up. In a different problem, I'll give you a system of equations and say solve it. So you still have to know the same two things, but I'm trying to do this in the fairest way possible to give you a good chance of doing well. But definitely the setup is what's important here. The solution, in case you're interested, would be A is 2, B is 4, and C is 6. So you can go verify that that's your solution, but we're just concentrating on the setup right now. How are we looking on problem number 10? Is everyone comfortable with the setup there? Where we got that from? Which numbers? The right-hand side of the equation, the coefficients? From this table, for each ounce of food A I eat, I get, say, 2 milligrams of C, 1 milligram of niacin, etc. Now, this was all given to us, so I don't know how many ounces I'm going to have in my final solution, but for every one of them, I have 1 times the number of ounces will give me the number of milligrams of niacin. For food group B, I get 2 milligrams per serving, or per ounce. So 2 times the number of ounces. Well, they tell us in the problem that we want to end up with 22 milligrams of niacin. So that's given to us, right? So the amount of niacin I get from A, so 1 times A, plus 2 milligrams from every serving of B, plus 2 more from every serving of C, has to total up to 22. The first equation is just dealing with the niacin. This is just the niacin equation. Yeah. I went down this column, did 1A, 2B, 2C. Yeah, we have to go down the table because it's just dealing with each nutrient. Okay. No, I'm glad you're on board. Is there anyone else that has some further questions? I really appreciate the questions. They help out a lot. One of the cool things that you can do with math, in particular polynomials that we've worked with, is find equations. So if I had, and you don't have to copy this down, I'm just kind of showing you a little bit about what you can do with certain equations. If I had, for instance, 2 points determine a line. So I can pick any 2 points I want in the world, and I can always connect them with a straight line. But what if I added, say, a 3rd point? Then how can I connect these? So this would be the equation y equals mx plus b. But what can I do for a 3rd equation, or for a 3rd point? Then how can I connect them? What do 3 points determine? They determine a triangle, but they also determine a parabola. And the equation of a parabola, the general one, or a general form of this, is y equals ax squared plus bx plus c. So if I have 3 points, then I determine a parabola. By the way, 4 points would determine a cubic function. So I can keep on adding points and then, just increasing the degree of my polynomial. We're going to stop here. We're going to stop right here with parabolas. Now the thing about these 3 points is that those 3 points, whatever the coordinates are going to satisfy this equation. So I can plug in the values for x and y from these 3 points, and it should fit. Let's see an example like this. They actually have a nice one in the book. Bless you. Because occasionally you'll get a comet that passes the sun in the orbit of a parabola. So that's your problem number 27. For problem number 28, they want us to figure out the curve that passes through these 3 points. So let me write those down. The coordinates, -1, -3, 1, -1, and 3, -7. Let me write them down here. So -1, -3, 1, -1, and 3, -7. Let's see how we do in trying to find an equation of a parabola that fits through those points. So I get y equals ax squared plus bx plus c. That's the general form of the equation of a parabola. If this parabola passes through points like -1, -3, then these should fit in this equation. So let's see what happens when I plug in this first point. Oops. So I'll get y, and the value for y is -3, equals -1 squared plus b times -1 plus c. Let's see if we can't simplify that equation. Nothing's going to happen on the left-hand side. You just get -3. But how about the right-hand side? Does that simplify it to anything? What happens when I square -1? -1 times -1 is +1, right? +1 times a is just a. So it's a. Kara, what about the rest of it? Good. So there's the first equation. -3 equals a minus b plus c. Thank you. Try and write down the next two. Do the same thing. Plug in values for y here and x here, and then simplify the equation. Try and come up with the next two equations. Let's see, we'll do Lauren, you get the next one, and then Dylan, the one below that. Lauren. Okay, how did that simplify? What equation do you get? So -1 equals a plus b plus c. Perfect. Colin, I mean, it should be Dylan. Yours is a little bit more challenging. What equation did you end up with? Times what? 3 squared is? So 9a plus there you go. So 9a plus 3b plus c. Cool. Thank you. This is your 3x3 system of equations. That's my goal here, is for you guys to be able to set up these systems of equations. Are you comfortable with what we did on problem number 28 here? If you take the time to solve this, you'll get a is -1, b is 1, and c is -1. Now, that's not the solution you're going to see in the back of the book, nor are you going to see -1, 1, -1. What you're going to see is them putting the values of a, b, and c back into this equation. So what you'll get is y equals -x squared plus x minus 1. Are you comfortable with that one? The setup on that one? Is it worth it to take a look to see that the parabola we created actually fits that? Sure. For giggles, let's take a quick look here. So let's get rid of this, and let's type out the points of -1. Let's try again. -1, comma -3, and then 1, comma -1, and finally 3, comma -7. So those are my 3 points. Let's see how my parabola does. Y equals -x squared plus x. Ooh, is it going to work? Is it going to work? -1. Bingo. Nailed it. So what we've done is come up with the equation of a parabola that passes through those 3 points. And you can do this for any 3 points. So it's kind of cool. Let's try problem number 30. Similar to problem number 28, we've got x squared plus y squared plus cx plus dy plus e equals 0. Let me switch over. Sorry about that. Now, this is the equation of a circle. I don't expect you to really be able to see that, but that's all right. This is the equation of a circle, and in the problem, they tell us that this circle passes through these points: 0, 0, 6, 0, and 3, comma 3. Well, this is pretty similar to the last one. They're giving you x, y for 3 points, and they're asking you to solve for the 3 unknowns. In this case, it's c, d, and e. Let's start with the first equation. If I plug in 0 for x and 0 for y, what equation will I get? Well, it'd be 0 squared plus 0 squared plus c times 0 plus d times 0 plus e equals 0. So that's plugging in 0. Yeah, you get a lot of simplification on this one, don't you? I mean, this is like uber. This is the mother of all simplifications. What do you end up with? E equals 0. So that's one of our equations. We need 2 more. I need those last two equations. How do these simplify? What do you end up with? Anyone? So 36 plus 6c plus e equals 0. Now typically you'd probably put that 36 on the right hand side. We'll worry about that in a minute. This one down here, you're going to get 9 plus 9 is 18 plus 3c plus 3d plus e equals 0. Let's clean these up a little bit. I get e equals 0. I'll move the 36 to the other side. 6c plus e equals 0. And moving the, thanks, negative 36. Negative 36. And moving the 18 to the right hand side. 3c plus 3d plus e equals negative 18. Okay. The final solution would give you, let's think, e equals 0. C equals negative 6. And D is actually going to be 0. If you plug that back into the original equation, what you'll be left with is x squared plus y squared plus negative 6c plus negative 6x plus 0y plus 0 equals 0. X squared minus 6y plus y squared equals 0 when it's all said and done. But the big thing, though, is the setup. And the setup is pretty much like our parabola one just a minute ago. If you're to check that on Desmos, then let's put in a 0 here, and again, it works. You've got a circle that passes nice and neatly through all three of those points. How are we looking on problem number 30? Okay there? All right with number 30? I want to do one last one. And again, we're just going to work on the setup. Mindy, I'm not sure if you want to close your eyes for this one or not. I don't know. It's problem number 12. A sculptor carves 3 types of statues with chainsaw. The number of hours required for carving, sanding, and painting a totem pole, a bear, and a deer are shown in the table. How many of each should be produced to use all the available labor hours? So he's got 14 hours to spend carving, 15 hours to spend sanding, 21 hours to spend painting. This one's a little bit different than our previous one. It's different in the sense that we're going to be going a little bit of a different direction in terms of coming up with our equations. What they're telling us is the time available for carving. Now that time is going to be used up carving totem poles, bears, and deer. So can you spot what's different about this one as opposed to our nutrition problem? Yeah, we're going to go across to get our equations, not down. Because we know how much time we're going to spend on carving. So all this time is going to be spent on carving. Now, if you were to do something like this for yourself, what you might want to do is give yourself variables that kind of reflect your problem. So T, B, and D. Maybe it's a little bit easier to relate to the problem at that point. So what's the first equation going to be then regarding how much time we have to spend carving? Yep. 2t plus 2b plus 1d, let's make that look like a D not an O, equals 14. Bless you. Why don't you try and come up with the other two equations? So the first equation for problem number 12 is 2t plus 2b plus 1d equals 14. Kennedy, what would be the next equation, please? Good? Perfect. And Abdulaziz, how about the one below that? Perfect. Are we on board with this one? Okay. So the final answer, and you can solve this at home, 2, 3, 2, and 4 for T, B, and D. So if you wanted to solve that one at home, that's great. That would be your solution. Cool. So faster than Golden State can blow a 3-1 lead in the championships. You're all done.
That was easy.
Cool. Let me give you some homework. For homework, try 9 through 13. '27, 29, and I'll let you pick one more, either 17 or 19. Any choices? 17, good choice. All right, so 9 through 13, 17, 27, and 29.